Okay, guys, welcome. Today we're going to talk about positive integer exponents and the rules that are associated with positive integer exponents. Okay, so one of the previous rules that we've already seen so far is the rule that if you multiply two numbers with the same base, then we simply add their exponents. And you can sort of use this to lead to the rule that if you have a number raised to an exponent and that entire expression raised to an exponent, then you're going to multiply those exponents. Okay, so we sort of looked at the rules for that before, so I don't want to spend too much time on them, but I do want to go over a couple examples just to be sure. Okay, so in part A, we have 2 squared all to the third power. Well, by our power to a power rule, we can multiply these exponents and we get 2 to the 6th. Right, and then if you multiply out 2 to the 6, 2 by itself 6 times, you should get that this is 64. Okay, in part B, we have x to the 4th all raised to the third power. Right, so if we multiply those exponents, we're going to get x to the 12th. Of course, since x is a variable, there's not much else we can do with that, so that's as far as we can take this one. Now in part C, we have x squared times x to the third all to the 4th. Right, so of course now we have multiple things going on, so we just want to handle this in the way that we handle all algebraic expressions, and that's we're going to use PEMDAS. Right, so of course we'll handle the parentheses first, and on the inside we're multiplying, so we need to add those exponents. And then now we have power to a power, so now here's when we'll multiply, so we'll get that this is x to the 20th. Okay, in part D, we have a squared all to the n power. Now, if we multiply those exponents, we get a to the 2n. Right? Now, part E, we have r to the n to the 2n. Right? Now, again, we're just multiplying here, so we have r to the n times 2n. And of course, this would give you an r to the 2n squared. Right? I just wanted to sort of write that out because you're going to get you're sort of getting an additional exponent within the exponent. And then finally, in part F, we have this expression x plus 2 raised to the 4th all squared. Right? Now, rather than distributing everything out in that 4th power, here we're just going to simplify this by multiplying those exponents, and this will become an x plus 2 all to the 8th. Okay, so those are a couple examples of the, so what happens when you multiply two numbers with the same base, and what happens if you take an expression that's raised to an exponent and raise that to another exponent. Okay, now let's look at the division rules for division of terms that have the same base. All right, so now essentially you can really summarize this rule regardless if m is greater than n is bigger than m, or if n is equal to m, you can always say that this is a to the m minus n, right? So you're just going to subtract here. And we'll sort of show this later sort of an equivalent way when we use negative exponents. But the way I like to think of it is wherever the bigger power is, so in this case, the top has the bigger power. So that's where you're going to end up with a to the difference of those exponents. Now, if n is bigger, that means that the bottom has the bigger power. Right, and when that happens, you're going to have your term with the exponent is going to be left in the bottom, right? And again, to that difference. Now, of course, if m and m are equal, then you have something over itself, and of course, that's always just 1. All right, so let's do a couple of examples of that. Now, in part A, we have 5 to the 7th over 5 to the 4. Right, so the bigger power is in the top, so that's where I'm going to have the leftover, and 7 minus 4 is 3. And of course, we can simplify this as a 125. Part B, we have negative 3 squared over negative 3 to the third. So this time, the negative is left in the bottom, or sorry, the exponent is bigger in the bottom. So we're going to get a 1 over negative 3 to the first. And of course, this is just going to give us a negative 1/3. Okay, part C, we have negative x to the 17th over x to the 11th. So we have a negative divided by a positive, so this will definitely be negative. And our bigger power is in the top, so we're going to have 6 left over in the top. Okay, part D, we have a negative 2y minus 1 to the 6 over a 2y minus 1 to the 8th. So we're definitely going to get a negative because negative divided by positive is negative. And now my bigger power is in the bottom, so I'm going to put a 1 up top, and I'm going to have 2y minus 1 squared left over. Okay, part E, we have x to the 2n plus 1 over x to the n. So of course, just as a sort of a refresher, this is 2n plus 1 minus n. So if we combine like terms there, we're going to get x to the n plus 1. Okay, and then finally in part F, we have a lot going on. We have x to the third all to the fourth up top. And in the bottom, we have x to the 7th times x squared to the 5th. Right, and I believe that's how it's written, yeah. Okay, so now if we simplify, so we'll simplify the top first, and that will give us x to the 12th. In the bottom, if we simplify the exponent first, we'll have x to the 7th times an x to the 10th. So then we'll get x to the 12th over x to the 17th because we're adding there. And then this is going to leave me with an x to the 5th in the bottom, so we're going to get a 1 over x to the 5th. All right, so those are a couple examples of the division rule for exponents. Okay, now we can show that if we take a product of two numbers and raise it to a power, then we can essentially almost distribute that m exponent to both a and b, right? And the reason why is it looks like this. ab to the m is just ab times ab times ab, where you have m of these things. Right? Well, if we reorder it, we can reorder it so that all the a's are first, and then put all the b's second, and there's m of each of those. So of course, this is just saying a to the m times b to the m, right? And you can sort of do something similar. Actually, the way that it works out for division is even easier because you're just doing multiplication of fractions. So that's even easier. Okay, so let's simplify a couple of examples. So in part A, we have 3 over 2 squared. So that's a 9 over 4. Because I should really do this in one extra step. Because this is 3 squared over 2 squared. So that's 9 over 4. Right? In part B, we have xy all to the 6. But this is x to the 6 times y to the 6. Right? Now part C, part D, part C and part D, I should say, look very similar, right? With one subtle difference. In part C, you have the negative outside, so that's negative is still going to be carried over. But then we get 2 to the 4th times x to the 4th. So we're going to get negative 16 x to the 4th. Right? In part D, now you have the negative on the inside. So now this is negative 2 to the fourth times x to the fourth. So now this is positive 16x to the fourth. So there's another example where you want to be careful with your exponents here. Part E, we have negative 2 over x all to the third. So this is negative 2 to the third over x to the third. So this is negative 8 over x to the third. Okay, part F, we have a 2x squared y to the fourth. So now if sort of in slow motion, we just raise each of these things to the fourth power. Well, 2 to the fourth we just saw was 16. Then we have an x squared to the fourth, so that's x to the eighth. And then y to the fourth is just y to the fourth. Okay, part G, we have negative ab squared over a c to the third, all raised to the third power. So in slow motion, this is the top raised to the third power over the bottom raised to the third power. But in the top, we have each of these terms here being raised to the third power. And c to the third in the bottom will just be c to the ninth. But then in the top, we're going to get a negative because a negative to an odd power is still negative. So a negative a to the third, b to the sixth over a c to the ninth. Okay, and then last but not least, part H, we have a 24y to the third. Oops. So 24 all in parentheses, 24y all to the third. And in the bottom, we have a 12x to the third. Okay, well, in the top, what we can actually do here is if you look at 24 to the third, that's going to be a big number, right? If you look at 12 to the third, that's going to be a big number. So I'm actually going to use the property in reverse this time. I'm going to say this is 24y over 12x, whole thing raised to the third. And now when I do that, I can simplify this 24 over 12. Right? If I do that, that's going to give me a 2 over 1, or just a 2y in the top and an x in the bottom. And now this is much easier to do because now we have 2y to the third up top and x to the third in the bottom. So we get an 8y to the third over x to the third. All right, so that one we had to be a little bit more careful with. Okay, so that concludes this video on positive integer exponents. I hope you enjoyed, and I'll see you next time.